In this video, we are going to solve the systems of equations in 5 different methods. The various methods of solving systems of linear equations are graphing method, substitution method, elimination method, row reduction method, and matrix method. To solve by graphing, first we have to solve the equation for y. That is, we have to put it in the form y is equal to mx plus b. And then if the line is already solved for y, you have to skip that step and graph the first line. The same way, repeat the process for the second line. That is, if it is not in the form y is equal to mx plus b, write it in that form. The intersection of the two lines will be the solution. The point of intersection of the two lines will be the solution to the system. If the lines are the same, then you will get infinite number of solutions. If the lines are parallel and if they do not intersect, then there are no solutions to the system. Let us solve this system y is equal to 2x minus 1, 11 equal to 3y plus x. The first equation is already in the form y is equal to mx plus b, so it is easy to graph it. And the second line we have to rewrite as y equal to negative 1/3 of x plus 11 by 3. We can graph both, and the point of intersection 2, 3 will be the solution to the system. Now, in order to solve the system by substitution, solve one of the equation for x or for y. This step can be skipped if one of the equations is already solved for x or y. Substitute the result whatever you got. Suppose if you got the value for x, substitute in the other equation, try to find the value of y. That is, you are writing y in terms of x and then you are trying to solve for y. Then plug in this value and try to get the other result. So to understand this part, let us take these two equations, 5y plus 3x equal to negative 10, x equal to 4y minus 9. The second equation is already is in the form x equal to a function of y. So you can substitute the second result in the first equation. So by substituting the second result x equal to 4y minus 9 in the first equation, you get 5y plus 3 times x in terms of y. So you get the whole equation in terms of y. You can solve for y. Y is 1. We can substitute this y equal to 1 in any one of those equations and get the value for x. So this negative 5, 1 will be the solution. The next method is solving by elimination. Now you have to get the x's and y's on the same side of the equation and find the common multiple of either the x or y, whichever we are trying to eliminate. Now if the two coefficients of x and y are not the same, then you have to make the coefficients to be the same by multiplying the coefficients to convert that into the same variable. So if you can add or subtract the two variable equations and then solve for one variable. Plug in the answer in any one of those two equations, try to find the third variable. Maybe to understand this, we can find the solution to this system by elimination method. So we have written the equation already lined up, x coefficients, x terms, y terms, and then the constant. But the coefficient of x and x are not the same, and even the coefficient of y are not the same. You can multiply the first equation by 3 and the second equation by 7 so that the coefficient of y becomes 21, 21. One is positive 21, the other one is negative 21. You have to multiply both the side of the equation by that constant. 3 must be multiplied throughout for the first equation. 7 is used to multiply the second equation. So adding them up, the y values will get cancelled out. You get 37x equal to negative 259 or x equal to negative 7. Now since we get the answer for one variable, we can plug in that in any one of those variables and get the second variable. So the solution is x equal to negative 7 and y equal to negative 6. And the next method is graphing method. So here let us see all different methods here: graphing method, substitution and elimination method. Graphing method, first of all, if the equation is not in terms of x, y isolated, you have to rewrite that in the form y equal to 3x minus 2, y equal to half of 10 minus x. We can enter that in your graphing calculator and you can easily find that 2, 4 is the point of intersection. If you are trying to use that same equation and try to get that in the substitution method, now you have to isolate y by itself. So since the second equation is y equal to 3x minus 2, you can plug in this result in the first equation and you get the value for x as 2. Substitute x equal to 2 in any one of those equations. You get the y value is 4. So 2, 4 is a solution. The same way, you can also use the elimination method. When you write the two equations one below the other, the coefficient of x and the coefficient of y are different. So if I want to equate the coefficient of y, only the first equation has to be multiplied by 2 throughout. So by multiplying that by 2, you get 6x minus 2y equal to 4, and the second equation is x plus 2y equal to 10. Adding them, y cancels out. You get the value for x as 2. Plugging in that result, you get y equal to 4. So if I'm trying to solve this system in terms of 3 variables using the row echelon form, then I use a matrix, that is the coefficient matrix and the constant matrix, the augmented matrix together, and I use the reduced row echelon form using for this augmented matrix. We can use TI-83 or 84, and we get the first coefficient matrix to be a unit matrix, and then the constant is 4, negative 2, 7. So 1x is 4, 1y is negative 2, 1z is 7, so x is 4, negative 2, 7. This is another method of finding it. We can also find this using inverse method. Suppose if I have the systems, the coefficient matrix and the variable as x, ax equal to b, then I can find the value for x by multiplying by the inverse of a. So x will be a inverse times b. So in this equation, if I can find ax equal to b, a inverse, you can enter that in your graphing calculator, get the result for a inverse, multiply that, and you can easily get the value for x1, x2, x3 as these 3 constants. Or we can also use the Cramer's rule by finding the determinant. The x value will be just the coefficient matrix, determinant of the coefficient matrix divided by the determinant of the matrix, which is replaced, the first column, the coefficient of x is replaced by the constant. If I am trying to find the y, the denominator will be the determinant delta y. Delta y is nothing but the determinant of the matrix obtained by replacing the y coefficient as the constant value. The same way, the second one is replaced by the z values are replaced by the coefficient. So you can easily get the value for x, y, and z. So delta x by delta, delta y by delta, and delta z by delta will give you the values of x, y, z. So this video helped us to understand all possible cases of solving it. Graphing method, substitution method, elimination method, and we also use the reduced row echelon form. We use the inverse method, inverse matrix, and also we used the Cramer's rule. Hope this video is helpful and you have learned various techniques of solving systems of linear equations. Thank you for watching and thank you for listening.